that you can see on the right hand side, the standing wave ratio, types of load, and the different wavelengths of transmission lines. These three topics today we will discuss. The first one coming to the standing wave ratio. If you try to recollect the concept of EM waves, where we have already calculated the standing wave ratio. So we have represented that with S in that EM waves. Now I am directly writing it as SWR, standing wave ratio, equal to S equal to, and it is the ratio of Vs max to the Vs min. Can you see the screen? Can you see what I'm writing?
Yes, sir.
Okay. So just I'm showing the solution what we have got for the transmission line equation Vs of Z. You can make this class interactive. Okay. Do you identify this solution that I have wrote?
Yes, sir.
Okay. So since I'm taking the ratio of the maximum voltage of the standing waves and the minimum voltage of the standing wave, so I'm writing it as, renaming it as voltage standing wave ratio. We call it as a VSWR, voltage standing wave ratio. And standing waves, in the sense, standing waves occur when the reflection coefficient is not equal to 0. That is a concept. Or I can say in another way, that when the maximum power is not being transferred or delivered to the load, then the standing wave occurs. That is a problem we are now addressing in the form of the standing wave ratio. So this we already know that is one of the solution for a transmission line equation, which is in the form of a voltage equation. Now let's go for, since see the formula it is, we need to find its absolute and find its maximum or minimum and then take the ratio. So we'll go for finding its magnitude first. So Vs of Z, I am going to apply modulus on both sides. Mod V naught plus e power of minus gamma Z plus V naught minus e power of gamma Z. Right? And next, if I am talking about a lossless transmission line, we have studied two cases. One is lossless transmission line, the other one is the distortionless transmission line. Now I am considering the concept of a lossless transmission line. Gamma generally we write it as alpha plus j beta, but for a lossless transmission line, alpha is 0. Okay, so therefore in this case, when alpha is 0, gamma will be j beta, which is purely imaginary. Right. Now let's substitute that gamma equal to j beta in the magnitude of Vs. Now you will get e power of minus j beta Z. You can talk along with me, otherwise it will be always one-sided. Accepted? Just give me the reply. Till this point, is it clear?
Yes, sir.
Okay.
Yes, sir.
Now let's go for taking the first quantity completely common. So 1 plus V naught minus e power of j beta Z by V naught plus e power of minus j beta Z, and you already have a modulus. Now recalling that what is gamma here? reflection coefficient. Am I right? So how we've calculated reflect coefficient is V naught minus by V naught plus. That you can see from the last class. So wherever I have that ratio, I can replace that with gamma. So mod Vs of z equal to mod V naught plus mod minus j beta z gain mod 1 plus V naught minus by V naught plus is replaced with gamma, and this is e power of j 2 beta z. Okay. Now, can you please tell me what is the value of this mod e power of minus j beta z? What is the value of this? Anyone can tell. What is the value of this? E power of minus j theta is written as cos plus j sine. If I am finding its magnitude, it means root over real part square plus imaginary part square. What is its value now?
1.
So replace that with 1. So therefore mod Vs of z equal to mod V naught plus, and that magnitude of complex exponential become 1, and this mod multiplied with 1 plus gamma times e power of j 2 beta z. Okay. And gamma reflection coefficient is a complex quantity. Why it is a complex quantity? If you can recollect the formula for gamma, can you please check me and tell me what is the formula for gamma? See your notes once and tell me. Anyone can answer.
ZL minus Z naught by ZL plus Z naught.
Okay, right? So since gamma is a complex quantity, why I am talking about complex in the sense? So this is dealing with the all impedances, where impedance is a complex quantity. So gamma can be represented in its polar form, that is magnitude and phase. So in the magnitude of Vs of z, I am now replacing that gamma with its polar form, mod gamma e power of j theta e power of j 2 beta z. Okay, now this is V naught plus 1 plus mod gamma. I'm just combining the power 2 beta z plus theta, and this e power of j 2 beta z plus theta can be represented in the trigonometric form like cos of 2 beta z plus theta plus j sine 2 beta z plus theta. Now replace that here. So mod Vs of z will be equal to mod V naught plus multiplied with mod 1 plus mod gamma cos of 2 beta z plus theta plus j times mod gamma sine of 2 beta z plus theta. Is this clear till this point?
Yes, sir.
Yeah. Now just observe This is a real quantity. This is a imaginary quantity for that. So if I try to find its magnitude, so it is mod V naught plus into, I am finding the mod of a complex quantity. That means it is root over, can you please tell me, real part square plus imaginary part square? You can do it. 1 plus mod gamma square, that is 1 plus a plus b whole square formula you can apply here. 2 beta z plus theta plus 2 mod gamma cos 2 beta z plus theta. This is a plus b whole square, that is real part square plus imaginary part square, that is mod gamma square sine square 2 beta z plus theta. Just we have applied. 1 minute. Just we have applied the formula of finding the magnitude of a complex quantity. Now you can observe that this part gamma square, mod gamma square cos square plus mod gamma square sin square can be replaced as mod gamma square, because cos square plus sin square is 1. So this I am writing again, mod v naught plus, so Vs of z mod is equal to under, can you please tell me now, simplified version, 1 plus
Mod gamma square
plus 2 mod gamma
2 cos 2 beta
z plus theta. Okay, so this is a simplified form of the magnitude of Vs of z. Now if I go back to the formula of VSWR, you can observe that it is a ratio of maxima to minima of this Vs of z magnitude. So therefore we will now find the maximum. So when this becomes maximum, can anyone see this? Already we did in EM waves. So cos can take plus 1 or minus 1. The maximum values of cosine function can be plus 1 or minus 1. Then it results a maxima. When it is minus 1, it results a minima. Okay. So now I am trying to write finally the maxima by taking cos value as 1. Cos of that entire function is 1. It is v naught plus mod under root 1 plus mod gamma square plus 2 mod gamma, because cos is taken as plus 1. So when this happens means when this cos of 2 beta z plus theta becomes 1 plus 1,
when, and when 2 beta z plus theta is equal to 0.
not only 0, let's go for a general solution. It is integer multiple of 2 pi. Okay, let's go for a general solution. The 0, this is a solution when n is equal to 0. So cos of 2 beta z plus theta is equal to plus 1 when this 2 beta z plus theta is integer multiple of 2 pi. So therefore the maxima is finally v naught plus, it is under root, this is just like 1 plus mod gamma whole square, and finally we have got it as v naught plus into 1 plus mod gamma. Clear till this point?
Yes, sir.
Yeah. Now we'll go for minima. That you can do, I hope. Under root 1 plus mod gamma square, and should I should I write here plus or minus for minima?
Ma-
Minus. Right. And cos of 2 beta z plus theta is equal to -1. When this goes to -1, anyone? When cosine becomes -1?
N pi.
No, 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 not n pi. It is odd multiple of pi. Okay? Odd multiple. That means pi, 3 pi, 5 pi. Cos becomes -1. So finally, Bs of z minima is mod v naught plus under root 1 minus mod gamma square. So this I can write it as v naught plus into 1 minus mod gamma. So finally you have got this one, Vs maxima and Vs minima. Can you please substitute these two in the final voltage standing wave ratio formula? Ratio V naught plus mod into 1 plus mod gamma by V naught plus mod into 1 plus 1 minus mod gamma. Okay, and that you can cancel both, and finally you will get 1 plus mod gamma by 1 minus mod gamma. Okay, so VSWR S formula is 1 plus mod gamma by 1 minus mod gamma. So this is a formula. So a small discussion here, like when the range for mod gamma will be 0 to 1. The what will be the range for S? Anyone? What will be the range for S now?
One to infinity.
Exactly, it is 1 to infinity. Nice. Okay. So the thing just I want to recollect is when gamma is equal to 0, that means no reflection. Okay. Now when gamma is equal to 0, S takes a value of 1, indicates that no standing waves. No standing waves. Okay. And when gamma takes either a value of +1 or -1, minus or +1, that means mod gamma is equal to 1. Then when mod gamma is equal to 1, S equal to 1 plus 1 by 1 minus 1, which leads to infinity. This is how we get this range 1 to infinity. And this S equal to infinity indicates that we have complete reflection. Complete reflection. And only standing waves are present. No power transmission to load. Only standing waves and no power is delivered to the load. Okay? Clear the concept? If you say yes, I'll go for the next one.
Yes, sir.
Yeah. Just recollecting. It is a ratio of Vs maxima to Vs minima. Then we took the solution of a transmission line equation. We found its absolute by simplifying it. And then we found the maxima and minima by depending on the cosine function. And after that, we took the ratio and simplified it. We got the expression of 1 plus mod gamma by 1 minus mod gamma. and you have to remember this formula to solve the problems.